Hey guys, I'll be talking about how to find derivatives of logarithmic functions and how to do logarithmic differentiation. First, I'll be talking about a few helpful logarithm laws. And the first one states that the natural log of a times b is the same as the natural log of a plus the natural log of b. The second law states that the natural log of a divided by b is the same as the natural log of a minus the natural log of b. And the third one states that if you have the natural log of a to the nth power, you can bring down the exponent to have n times the natural log of a. And the natural log can also be a log base x of a times b, so it'll just be the log base x of a plus the log base x of b. And the fourth one is called the change of base formula. And this is saying that if you have log base a of b, that is the same thing as a log of b over the log of a, which is also the same as the natural log of b over the natural log of a. The derivative of logarithms. When you're finding the derivative of log base a of u, you take the derivative of u and you divide it by the natural log of a times u. So this is the formula you'll be using to solve the problems. The derivative of the natural log of u is the same as finding the derivative of u divided by u when u is greater than 0. If u is a negative number, you get error. Now a helpful hint is that finding the derivative of the natural log of u is the same as finding the derivative of log base e of u. So then you could also use this formula to find the natural log of u, the derivative of it. So then you do the derivative of u divided by the natural log of e times u. And since the natural log of e is the same thing as 1, you get in the end the derivative of u divided by u, which is the same you see here. So let's do some practice problems now. So the first problem is find the derivative of y equals the natural log of 2x. So first we're going to use the logarithm laws to expand the natural log of 2x to get y equals the natural log of 2 plus the natural log of x. Then we're going to take the derivative of everything to get y prime equals the derivative of natural log of 2 plus the derivative of natural log of x. Now the derivative of a constant number is going to be 0. And the derivative of the natural log of x, we use the formula u prime over u to get 1 over x. The derivative of x is 1, and you divide it by x. So you get y prime equals 1 over x. Another problem we have is find the derivative of y equals the natural log of x squared. So we're going to use the logarithm law again, and we're going to bring the exponent down to the front, so we get y equals 2 times the natural log of x. Then we're going to find the derivative of everything, so it'll be y prime equals 2 times the derivative of the natural log of x. Again, we use the formula that we established before to find that the derivative of the natural log of x is 1 over x times 2. So in the end, you get y prime equals 2 over x. Now a helpful hint is to keep track of which step you're finding the derivative, because in your work you can forget if you had already found the derivative or not. So it's really helpful to say to use y, and then when you find the derivative, use y prime. The third problem asks to find the derivative of y equals the natural log of sine 2x times the square root of x squared plus 1. So first we'll be using logarithm laws to expand it to get natural log of sine 2x plus the natural log of x squared plus 1 to the 1/2, which is the same thing as x squared plus 1 under the radical. Now we change it to the 1/2 because we can then use the other logarithm law to bring it down to get 1/2 times the natural log of x squared plus 1. Then we're going to find the derivative of everything to get y prime equals cosine 2x over sine 2x times 2 plus 1/2 times 2x over x squared plus 1. So, using u prime over u, which was the formula to finding the derivative of a natural log, we get the derivative of sine 2x cosine 2x over u sine 2x times 2 because of chain rule. And you add it to 1/2 times 2x over x squared plus 1. The derivative of x squared plus 1 is 2x over x squared plus 1. Now if you simplify it, you get 2 times cotangent 2x plus x over x squared plus 1. Now the fourth problem asks to find the derivative of y equals x times the natural log of x cubed. So this is the same thing as this. You're cubing the natural log of x. So we're going to find the derivative of all this and get y prime equals x times 3 times the natural log of x squared times 1 over x plus the natural log of x cubed times 1. Now we use the product rule for this, and we find the derivative of the natural log of x cubed to get this, and then we find the derivative of x to get 1. Simplified, x and x cancel out, get 3 times the natural log of x squared plus the natural log of x cubed. And if you would like, you can factor out the natural log of x squared, and you get the natural log of x squared times 3 plus the natural log of x. Now a common mistake is that people will see the natural log of x cubed, and they'll think that that is the same thing as the natural log of x cubed. But we can't use the logarithm law for this, because we can only use it when x by itself is being cubed, not the whole thing. Now I'll be going over how to do logarithmic differentiation. So the first step is to take the natural log of both sides of the function that you want to differentiate. So if you had y equals u, and you want to find the derivative of that, you take the natural log of both sides. Now the second step is you use the logarithm laws, if need be, on the natural log of u, and you expand it. Then you use implicit differentiation. So then you'd get y prime over y is equal to the derivative of the natural log of u. Again, we get y prime over y because the derivative of the natural log of u, we use the formula u prime over u, so it would be y prime over y. Y prime over y. Now the fourth step is to move everything but y prime to one side of the equation. So you just multiply y to this, and you get y prime equals y times the derivative of the natural log of u. Now the last step is to plug in the u from the original equation, the u, for y. So you get y prime equals u times the derivative of the natural log of u. Let's do some practice problems using logarithmic differentiation. So we have, find the derivative of y equals x to the ex power. So you take the natural log of both sides, and using the logarithm laws, we bring down the exponent down in front of the natural log of x. Then we take the derivative of everything to get y prime over y is equal to e to the x times 1 over x plus e to the x times the natural log of x. We're using product rule here, so we do e to the x times the derivative of the natural log of x, which is 1 over x, plus the derivative of ex, which is ex, times the natural log of x. Now we make sure that both of them have the same common denominator, so we can add them together, as shown here. And in this step we also factored out e to the x. Now we multiplied both sides by y, so we can move it over here and keep y prime by itself. And we substituted y with the original equation we had here. So it would be y prime equals x to the e to the x times e to the x times 1 plus x natural log of x over x.